I found out about this time station emulator project on Hacker News, and it's a WWVB time signal emulator, and it kind of simulates the signal that's broadcast out of Colorado for timing, and it's used for like watches and clocks and things like that that have atomic time. It doesn't mean that those clocks have atomic clocks inside of them. That'd be kind of crazy, but very cool if that ever happens. But instead they have a little antenna in them that receives the signal on 60 kilohertz. So what I have here is, this is just a web app. It's like timestation.pages.dev, and you have to have speakers connected to your computer. I have my speakers here, and it will play a sound through them at like 1 kilohertz, but it'll be inaudible unless you put your ears right up to the speakers. Don't do that. But anyway, it'll be inaudible to humans pretty much, but you can see that there is a signal being passed through, and that is the timing kind of encoded signal that every minute it will give a clock the time. So if you ever have a clock that is having trouble getting time, you could set up like a speaker next to it with this running, and supposedly this would give it the right time. To test that out, I have my Hydra SDR sitting here, it's actually down here, along with a Ham It Up from Eck. And the Ham It Up, what it does is it takes low signals like 60 hertz, and it kind of boosts it up to 125 megahertz, specifically 125.06 megahertz, so that devices like a Hydra SDR or pretty much any SDR that is in the more standard ranges in the megahertz range can listen to these low frequency signals. And I have that with this antenna here, and this is weird. Like, this is really weird to me. My speaker is playing a sound, and that sound is inducing RF into this antenna. That's just weird. I don't understand the physics of how that works, but apparently you can do it. And if you want to read more about that, look up, I think it's Eck Phreaking, and not spelled F-R-E-A-K, it's P-H-R-E-A-K. Look that up and you can find out more about that. But yeah, my speaker is a radio antenna, basically, playing sound waves that induce voltages in here that go through those two boxes into my SDR software, which I'm running GQRX here. And you can't really see it in the waterfall, so I'm tuned at 125.06, which is, with the Ham It Up, that means it's 60 hertz, or 60 kilohertz, sorry. And you can't really see it there, but let me play it back for you. And this is not playing, so here's what I'm going to do. This is muted right now, and if I turn this sound up, you can't hear anything. I can't hear anything, but the sound is playing through the speakers. It's probably giving me a headache or something, but I'm going to turn that back down a little bit. But I'm going to unmute the sound from GQRX, and you'll hear the signal coming through from the speaker into this, and then into the SDR, and then played back through the computer that's decoded the timing signal. So here goes. So can you hear that sound? It corresponds to what's on the screen here. So that is just crazy. Like, it's playing that sound through the speakers that's inducing RF into this antenna. It's decoding it in SDR and giving me the timing signal. Now, it's not an amazingly clear signal. Like, if I set up a better antenna and had a better radio for this, it would be much more clear, I think. But the idea is that you could play this back on a computer or Raspberry Pi, maybe even your phone. I haven't tried that. And play it straight into an area where one of your clocks is that might not be getting the time signal, and this would give it the time. So this is obviously not an atomic clock. This is just using NTP on your computer, but that's really cool. And I thought I'd show you this little demo that I have running, because I didn't think this would work, but it does, like magic. RF is very weird, and this is a demonstration of how weird it can be.